Rules. So, lecture 14. This is going to be all about the exponent rules. And there are 5 of them. 5 exponent rules. Okay? So when I'm talking about exponent rules, we're going to be looking at variables, coefficients, and exponents. So the way I usually teach this in class is you're going to have something like ax to the n power. Ax to the n power. Where a is going to be a coefficient. A is going to be a coefficient. X is going to be a variable. X is going to be a variable. And n is going to be the exponent. N is going to be the exponent. So let me zoom in on that so you guys can see it. We're going to be looking at this term right here. It is ax to the n power, where a is a coefficient. A is going to be the big number out in front. That's called the coefficient, right? It's usually going to be a whole number, but you can also see it as a fraction in some places. So that's called the coefficient. That's A. Now, the variable is going to be x. Sometimes we use y, sometimes we use z, but for now, our variable is just going to be x. And n is the exponent. That's going to be that small number above the x. You know, the exponent can be negative, it could be 0, it could be positive. And we've already talked about what happens when your exponent is positive and when it's 0 and when it's negative. But we are going to be incorporating some of those rules today when we talk about the 5 exponent rules. Okay? So let's go ahead and get started with the exponent rules. There are 5 of them that you need to know to pass this week. They are number 1, the product rule. So let's talk about the product rule. Now, when we say product rule, we're really going to hone in on the word product. So I'm going to underline product in red. You can underline it in pencil if you want. And basically what product is going to mean is product means we're multiplying, right? So I'm going to draw an arrow down here and I'm going to say we are doing multiplication. Multiplication, right? So when you have 2 numbers and you multiply them together, the answer is going to be the product of those 2 numbers, right? So when I say the word product, you're going to immediately think of multiplication. That's what we're talking about. So when we multiply, what we're actually going to be doing is we're going to be adding exponents. And you'll see how that happens in a minute. So let's say we're doing the product rule and we have a variable x. And that x is going to be raised to the m power. Okay? So x is the variable and m is going to be our exponent. Now, we're going to be multiplying because that's what product means. So I need a dot to go in the middle. So the dot goes in the middle because we're multiplying, and we have the same variable here, right? The x. But this time, the exponent is going to be n instead of m. Okay? So when we do that, what's going to happen? Well, if we're multiplying, the variable is actually going to stay the same. So the x is going to stay the way it is, but we're actually going to be adding the exponents. You're going to get m plus n. Okay? So when you multiply x's together, you're actually adding the exponents. So let me write that down here. When you're multiplying, you are adding exponents. And I think that's pretty plain to see from my little formula right here. Notice that the dot in the middle means we're multiplying, and this plus sign in the middle means that we're adding. So we're obviously going to be adding the exponents for these rules. Okay? So let's look at the problem set. I wanted to look at a couple problems from there. Okay. So on your problem set, also known as practice set, we have 5 problems that we're going to do, and we're just going to do them one at a time. So let's do number 1 together. I've got x to the 8th power times x to the 3rd power. Okay? So we're going to be looking at this one for the first one. Now, I've got 8 and I've got 3. And since I'm multiplying the variables together, that means I have to add the exponents, right? So what's going to happen? I'm going to draw my equal sign. The variable is going to stay the same, but the exponent is going to become 8 plus 3, which you know is 11. So I'm going to have x to the 11th power. That's my answer. And really all I'm doing is I'm adding the exponents. And once we get good at these, you won't have to show your middle step like I did right here, but eventually you'll just get to the answer first of all. Okay? So let's look at the next problem. On the next problem, we have x to the 7th power times x to the 9th power. Go ahead and try this one on your own. I'll give you guys a few seconds to try that. It should be really simple. All you're doing is you're adding the exponents. So go ahead and try that. And then while you're doing that, I'll be writing down the next 3 problems. Okay, so for number 2, we're going to be adding the exponents. So I'm actually going to have x, but I'm going to have it to the 7 plus 9 power. And we know that 7 plus 9 is 16. So you should get x to the 16th power, right? Because we're just adding 7 and 9 together. Okay? So next we're going to be doing 2 plus 2. So I'm going to have x to the 2 plus 2 power. And that's going to give me x to the 4th power. So all we're doing so far is we're adding the exponents. So that's what you do when you're multiplying the variables together. And you'll know you're multiplying if you have a dot in the middle, or you also know you're multiplying if you have parentheses, right? You could have a set of parentheses right here, and you can have a set of parentheses right here. And that tips you off to, hey, I'm supposed to be multiplying these. Now, when we do number 4, we actually have coefficients to deal with, right? Remember those big numbers out in front that I was talking about? Those are called the coefficients. So we're going to be looking at those next. Now, looking at these, we're actually going to multiply the coefficients together. So 3 times 2 is going to give me 6. So that's what I do first. I multiply 3 and 2 together. The next thing I'm going to do is, like usual, I'm going to add the exponents. So what's 8 plus 4? That's going to give you x to the 12th. Okay? So that's the difference between number 4 and number 3. Notice for number 3, you don't have any coefficients, or at least the coefficients are assumed to be 1s, right? And 1 times 1 is 1, so you don't really have to worry about the coefficients for 1 through 3. But for number 4 and number 5, notice that you have to multiply first. So now, doing number 5, what happens when we multiply -5 times a +4, right? That should give you a -20. So I've got -20, and what do the exponents give me when I add them up? Well, I've got a 2 right here, and I've actually got a 1 right here. At least it's assumed to be 1 if I don't write it. Okay, so 2 plus 1 is going to give me 3. And I think that's pretty obvious. So you're going to have -20 x cubed. So that's the product rule. You're basically adding exponents. The next rule is going to be called the quotient rule. Here you're going to be dividing, and because you're dividing, you're going to actually be not adding, but subtracting exponents. So let's take a look at rule number 2. Rule number 2. This is going to be called the quotient rule. The quotient rule. All right. So rule number 2 is going to be called the quotient rule. I'm going to underline quotient because it does mean something. How do we get a quotient? Well, basically, when we divide two numbers, right? So this is division. Division. Whenever I take two numbers and I divide them together, we're going to get what's called the quotient. So for example, if we have 8 divided by 4, I would get 2. 8 divided by 4 gives me 2. So the quotient is going to be 2, right? So when I say the word quotient, you should immediately think of we're dividing this time. And because we're dividing, we're going to be doing the opposite of adding the exponents. Like rule number 1, we're going to be subtracting exponents. So this is going to be subtracting. Subtracting exponents. Okay? So let's write out the formula. I'm going to have x to the m power, x to the m power. Notice that x is the variable and m is the exponent. We're going to be using a division symbol, which is our normal division symbol, right? A line with 2 dots. And we're going to have x to the n power. X to the n power. So what does this equal? Well, the variable is going to stay the same. We're going to have our x, and we're going to be subtracting m and n together. So m minus n. So that's basically the formula that we're going to be using today for the quotient rule. So really this means when you're dividing x's together, you have to subtract the exponents, which is pretty simple to remember. Now, you can also see the rule written like this. You could also see it written as x to the m power divided by x to the n power. So notice this is a fraction. Our numerator is going to be x to the m, and our denominator is going to be x to the n, as long as x to the n power doesn't equal 0, right? Because then you'd be dividing by 0. But anyways, notice this is the same thing as this. So you would still get x to the m minus n. You would still get x to the m minus n. Okay? So just one formula, 2 ways to write it. Okay? Let's look at the problem set for these. We're going to do 1 through 5. So number 1 says what? X to the 8th power divided by x to the 3rd power, or x cubed. That's another way to say that. So what would happen here? Well, instead of adding the exponents, since we're dividing, I'm going to subtract them. So you should get x to the 8 minus 3, which is indeed 5. So x to the 5th power. Okay? And it's as simple as that. We're going to be subtracting exponents. So let's look at number 2 and number 3. I'm going to let you guys try 2 and 3 on your own. And then we're going to do them together. X to the 17th power divided by x to the 4th power, and x to the negative 2 power divided by x cubed. Okay, so go ahead and try those 2 on your own. I'll give you guys a minute to try that. And while you're doing those, I'll write down 4 and 5. All right, let's go ahead and try them out. So for number 2, you're going to be subtracting. We're going to have 17 minus 4, and that should get you x to the 13th power. For number 3, we're still subtracting. So I'm going to have x to the negative 2 minus 3. That's actually x to the negative 5. X to the negative 5. And if you're confused over that, just remember that you have a negative number minus another number, so you're becoming even more negative than you were, right? Okay, so all we're doing is we're subtracting exponents. Now let's deal with 4 and 5. So looking at number 4, the big numbers out in front are called the coefficients, right? So I'm going to actually be dividing those, but I'm going to be subtracting the exponents. So 2 different ways of thinking about it. We can do the big numbers first and then get the small numbers. So looking at the big numbers out in front, what is 20 divided by 10? 20 divided by 10. That would be 2, right? So I'm going to have a 2. And then we're not going to be dividing exponents though, right? We're actually going to be subtracting. So what's 6 minus 2? That's going to be x to the 4th power. There you go. Okay, so now let's try number 5. Right here, I have 12 divided by 3. Well, we know that 12 divided by 3 is going to be 4. So 4 comes first. That's going to be the coefficient. And then we have to deal with the exponents. So now we have 26 minus 14. 26 minus 14 is 12. So you should have x to the 12th. So that's rule number 2. That is called the quotient rule. So I'll leave that up there for about a minute, and we're going to talk about rule number 3 next. Rule number 3 is going to be called the power rule. So what you're probably noticing with the last 2 problems is that the big numbers don't play by the same rules as the exponents do. And that's to be expected. You know, the coefficients are a little bit different from the exponents. The exponents actually deal with how many variables you have, right? So looking at this one, I have 4 x's right here, right? 4 x's. And my coefficient is 2. That's really the difference between the big numbers and the small numbers, okay? All right, let's look at the power rule, number 3. So the power rule, it all hinges on the word power, right? When I say power, that really means that I'm taking something to an exponent, or I'm taking something to a power. So I'm going to underline the word power, and underneath that, we're going to write taking an expression, an algebraic expression, to a power. And when I say power, I could also say exponent, right? Because these are really the same words in math. Power and exponent, pretty much the same word. Okay? So what do we do when this happens? Well, basically, you're going to have a set of parentheses, right? Let's say I have x to the m power inside parentheses. X to the m power. X is my variable, and m is my exponent. But let's say I'm taking an exponent to an exponent. So I'm going to raise everything on the inside to the n power, the n. So I'm going to write an n right here, okay? So what does this mean? Well, what it means is I've got x to the m power on the inside, right? And I'm taking everything on the inside to the n power. So what does this give us? This is going to give us x to the m times n. Or you could also write it as x to the m times n with a dot. So these two things are really the same thing. What you're actually doing here is you're multiplying the exponents together. So under this, I'm going to write multiplying exponents. And this makes sense, right? Because the first two rules, you were either adding the exponents or you were subtracting the exponents, right? Here, you're actually going to multiply the exponents together. So let's see how that works. We're going to look at number one. Number one says we got x cubed. We got x cubed, right? That's on the inside. And we're raising the whole thing to the what power? The fourth power. So what I want to do is I want to raise everything on the inside of this parentheses to the fourth power. Okay, so my m in this situation is going to be 3. My n in this situation is going to be 4. So what happens here? I have x to the 3 times 4 power. Since we're multiplying the exponents together, 3 times 4, that should give you 12. So this is really x to the 12th power. And if you wanted to skip that middle step, you could. Okay, so we are multiplying exponents now. Let's try number 2 and number 3. So 2 says x to the 8th power, and we're cubing everything. We're cubing everything. That means we're raising it to the 3rd power. And then for the next problem, number 3, I'm actually going to have a negative exponent on the inside. So x to the negative 2 power, and we're going to raise everything to the 10th power. So go ahead and try these two. Take a minute, see if you can get them before I get them. They should be super easy. All you're doing is you're multiplying the exponents together. And I will write down 4 and 5. Two x cubed, everything to the 4th power, and we have 3x to the negative 1 power, where everything is cubed. Okay. So go ahead, be finishing up number 2 and number 3, and then we'll talk about it. All right. So I have x to the 8th power, and I'm cubing everything. So what's 8 times 3? That's going to be 24. So you should get x to the 24th power. Okay? Let's look at number 3. I've got x to the negative 2 power, and I'm raising everything to the 10th power. So negative 2 times 10, that should give you negative 20, right? Okay, good. So now looking at number 4 and number 5, what's the difference between number 3 and number 4? Well, just looking at it, it looks like number 4 has a coefficient out in front. So that's going to have a different rule associated with it. So just like before, we are going to do something different to the coefficient than we're going to do to the exponent, right? So looking at number 4, I've got 2 out in front. I've got that 2 out in front, right? But what am I doing to it really? Well, I'm multiplying it by x cubed. Yeah, we know that's true. But also what I'm doing is I'm taking that 2 and I'm raising it to the 4th power. So this is actually 2 to the 4th power. So I'm going to take it out as 2 to the 4th power. But then I'm still going to have that x cubed on the inside, and I'm also raising that to the 4th power. Okay? So 2 different things we're doing. All right? So that coefficient is a 2. I'm raising it to the 4th power. So that begs the question, what is 2 to the 4th power? 2 to the 4th power, that's actually 16. 16. Right? Because when I have 2 to the 4th power, what I'm really doing is I'm doing 2 times 2 times 2 times 2. Okay? Notice how I have 4 2's together? And when I multiply all these together, you should get 16 because I'm really doing 4 times 4 at this point. So 4 2's, right? That should give you 16. So now let's look at the x's. We're supposed to be multiplying the exponents, right? So what's 3 times 4? 3 times 4, that should give you 12. So you should get x to the 12th at the very end, and you're done. Okay? Let's look at number 5. For number 5, what's my coefficient? My coefficient is 3, but my exponent is also 3, right? So my coefficient can be brought out as a 3. And what am I doing with the 3? I'm raising it to the 3rd power. So 3 to the 3rd power. We're going to be doing that next. And then the variable, that can be inside of its parentheses. It could stay there. X to the negative 1 power, and we're cubing it, right? So that's what we're going to be doing next. We're going to be figuring out what 3 cubed is, and then we're going to be multiplying the exponents together. So looking at the coefficient, I've got 3 cubed. What would that be? Well, doing it up here, I have 3 times 3 times 3. That's what 3 cubed is. And we know that 3 times 3 times 3 is 27. 27. Because at this point, what you're really doing is you're doing 9 times 3. And I think that's pretty obvious. But you are going to have 27 for a coefficient. And when you multiply the exponents together for the x's, you're going to get negative 3. So x to the negative 3 power. And that's the power rule. That's pretty much it. You're raising everything to a power, right? So everything inside the parentheses is being raised to the 3rd power. Over here on this one, everything inside the parentheses is being raised to the 4th power, right? So the 2 is being raised to the 4th power, but the 3 is also being raised to the 3rd power. You've got to understand that the coefficient is doing something different than the exponent. Okay, now we're ready for the 4th rule. And then the 5th, and then we're done. So the 4th rule is the negative exponent rule. The negative exponent rule. The negative exponent rule. All right. So when I say negative exponent, and I'll go ahead and underline that in red so you see what I'm talking about, what I really mean is the exponent is always going to be a negative number when we talk about this rule. So what I've got here is I've got x raised to the negative n power, and we're going to see what that is in a little bit. So we've already kind of talked about this before. Positive exponents, those are going to be positive numbers. Negative exponents, these are going to be negative numbers. And this is actually going to become a fraction. It's going to become a fraction where 1 is always on top. 1 is always going to be on top. So the numerator is always going to be 1, but the denominator is going to be x to the positive, whatever number you have. So it's actually going to be x to the n power on the bottom. So 1 over x to the n power. That's going to be my denominator, right? So looking at this, I have x to the negative n, And I'm starting out with a negative number, right? I'm starting out with a negative number. Let me label that. This is a negative number. So I start off with a negative number, but when I apply the rule to it, it's actually going to change to becoming a positive number. So over here, we're going to label this as positive because it just flipped from being a negative to a positive. Okay? But do take caution that you always put 1 at the top. There's always going to be a positive 1 at the top, no matter what. So let's look at the first problem on the problem set. And I've got 5 that I want to do. So the first one is we're going to rewrite an expression. We're going to rewrite x to the negative 2 power. And we're pretty much going to do that for all 5 of these. Okay. We're going to rewrite x to the negative 8. We're also going to be rewriting x to the negative 19, x to the negative 1 power, and x to the negative 6. Okay. So for this first one, we have x to the negative 2 power, right? And when you do this one, you start off with a negative number. So I'm going to draw my equal sign. I'm always going to put 1 at the top because positive 1 is always at the top when you do these kinds of problems. And it's going to become a positive 2 at the bottom. So you're going to have x squared at the bottom. And make sure you put that x with your answer or it's going to be wrong. Okay? Same thing with number 2. I've got x to the negative 8 power. So it's going to become 1 over what? 1 over x to the positive 8. Notice how a negative number always becomes a positive in the denominator, right? That's how we're going to be using negative exponents. So go ahead and try these 3 on your own. Go ahead and take a minute on that, and then we'll talk about these 3. So after we do these 3, we're going to get to the 5th rule, which is the final rule we're going to talk about today. Notice that we always have a positive 1 at the top. So I'm always going to have 1 over something. Okay, so number 3, I've got x to the negative 19th power. So it's going to become a positive 19 in the denominator. So 1 over x to the 19th power. For number 4, I start off with a negative 1, but it's going to become a positive 1 in the denominator. So it's going to be x to the 1 power, or I could always write this as just an x, right? Same thing. So all these get check marks. So then the last one, x to the negative 6 power, is going to become x to the positive 6 in the denominator. And that's it. That is the negative exponent rule. Okay? I'll leave that up there for about a minute so you guys can finish up. And we'll look at rule number 5. And then it'll be time for me to go. All right. So the final rule is going to be called the zero exponent rule. The zero exponent rule. So number 4, we talked about what happens when your exponent is negative. We've also touched upon what happens when your exponent is positive. Really nothing happens. But the fifth rule is going to be called the zero exponent rule. So let's talk about this one. When we're talking about a zero exponent, I really mean that your exponent is literally going to be zero. So when I say zero exponent, that means you're going to have zero for an exponent. So I'm going to underline the zero exponent in red. Okay, so what happens here? You're going to have a variable. You might have a coefficient out in front, but we're going to leave that off for now. And your variable is going to be raised to the zero power. Now, your exponent can be zero. And whenever you have something to the zero power, you're always going to get 1 in return. So you're always going to get 1. So in this sense, your answer is really simple. It's always going to be 1. But there is a catch, and we'll see that later. Okay? Let's try 5 problems like that. So the first one, what I want to do is I want to raise x to the 0 power, and then I want to raise y to the 0 power, and I want to raise z to the 0 power. And we're going to see what happens when we do that. Okay, so go ahead and write those down, and we'll talk about them. Now your exponent is 0, and there's no coefficient. You could also think about it as, well, if I don't have a coefficient, then the big number out in front is always going to be a 1, or at least it's assumed to be. So there's really no need to worry about coefficients for now. All right, so let's do number 1 together. I've got x to the 0 power. So I'm going to have a 1 for my answer, because anything to the 0 power is going to give me 1. So it's the same way with number 2 and number 3. You're going to get 1s, right? Y to the 0 power is 1. Z to the 0 power is 1. And we can even do these with numbers. So let's try the next 3. 4, 5, and 6. Here I have 2 to the 0 power. I've got 1 to the 0 power. And I've got -3 to the 0 power. So we're going to be looking at what these 3 are. I'll give you a minute to go ahead and copy those down, and then we'll talk about them. And then hopefully, maybe if I have a little bit of time at the end, I can fully explain why this rule is true. Okay? So now I've got whole numbers raised to the 0 power. But luckily, the rule still holds, right? Anything to the 0 power is going to be 1. So 2 to the 0 power is going to be 1. 1 to the 0 power is going to be 1. And even a negative number raised to the 0 power is going to be a 1. So notice you're getting 1s for all your answers. You should be, because anything to the 0 power is 1. That's the rule. Now, what happens if instead of having a -3 right there, I had the negative on the outside? So let's say I had -3 raised to the 0 power. Let's try this one. Now, notice this one is a little bit different from the last one that we did. For number 6, I've got -3 raised to the 0 power. But here, I've actually got something a little bit different. Notice that there's no parentheses. That means that we have a +3 raised to the 0 power, but the negative is out in front. So you could think about it as my coefficient is -1, and 3 is going to be my variable. That's another way you can think about it. So really what happens here is instead of getting a +1 for your answer, like you usually do, you're actually going to get a -1. So these two are not the same, obviously. They are 2 different problems, and I'll show you why. Notice how the parentheses are missing? Well, what this does is it brings the negative over, but 3 raised to the 0 power is still a +1, right? So you would actually have -+1, which is -1. And that's basically the difference between this problem and this problem. Here you have parentheses, while over here on this side, you don't have those parentheses. So your math is going to change. Okay. So here's the last problem I wanted to talk about. Number 7. What is 0 to the 0 power? 0 to the 0 power. This one is actually undefined. So I'm going to write undefined. So 0 to the 0 power is traditionally undefined. And that just means you don't get a number for your answer. You actually don't get an answer at all because there's no way to define the answer for this problem. So the 0 exponent rule says anything to the 0 power is 1 except for 0 to the 0 power. That's always going to be undefined. So I'm going to add a quick stipulation to this rule. This is only for numbers that are not 0. Because if x actually was 0, you would get that undefined situation. But any number other than 0, you can raise it to the 0 power and get 1 every single time. Okay? That's pretty much it. That's the 5 exponent rules.